G'day and welcome to my garage. Still got to clean up in there. That's a low area. I'll have to think about that. See what I can do with that. I'll cut this off later. The areas you see here, this is pretty good this side. I've got a little bit to take out there. But I should be able to just clean this up with a little drum sander in the Dremel type machine. But this side's a lot worse. Plus I've got a cavity there, so I've got to dig as much of this out so the drum sander's got a better chance of working. So I can't get anything really in there except for a hammer and chisel. So let's continue. Continue on this piece. You'd get the gist of it by now. I'll keep going. You can go to sleep. As you can see, I've ground this chisel into a parrot's beak, relieved the back edge there so I can get further around. Yeah, it works quite well. It's just a little bit at a time. And of course the technique with the hammer, I'll just bring you out a bit. Technique with the hammer is going from there around to there. I can feel that. If I just hit it straight, it wants to go in, but I need to go around a curve. So I've got to hit it on that corner just right. But it's coming up nice. Bloke ought to get a milling machine to do this. Oh, that's right, that's what this is. It's like sculpturing. Okay, the little electric die grinder and little drum sander will finish that off, I hope. Alright, catch you later. Well, I've drilled the 3 holes for the the arced slot that has to go in here, and this should give me enough room to get a socket onto the nut, the T-nut that comes up through from the base. So I just need to clean this area off in here. Now the other side is, I had a lot of build up in here and I chiselled most of it out, but still worried about whether it was going to work or not. But to my surprise, a wood bit works very nicely on aluminium. I don't think it'll be able to go all the way through, but I only need just to skim it off. So I'll demonstrate that yes, you can use a simple speed board, just one of these, to and yeah, now it's not quite flat across there. It tapers down to the centre, but I'm not too worried about that. I think I can live with that. I was quite successful. I knew because of that, the cutting face not being square, I knew I was going to end up with a little bit of gouging going on. But no, that will work out. I can get a file in here now to bring this out to the outside edge, and once I get this outside edge away, I can then file that inner edge. That looks good. That will work. So I'll catch you later. I make the same mistake nearly every time. I machine away and go, oh, forgot to turn the camera on. But oh well, here we go. We're mounted to the faceplate. Just cleaning up this edge here. Then I've got to drill a 16mm hole for the nag, for that plug. A little bit more still. Okay, the rest of that will clean up. Oh, I recommend you don't throw your 12mm bits around.
What are we up to? Okay.
15.03. Let's zero that. Where's my... I've got 0.68. Maybe 1mm. This isn't quite round. Say 0.64. So 32, 0.32. Right, we have the Quill Support on show. Now, as part of the final operation to put the boring bar through there and drill the main spindle journal, part of that operation is to create the same as what we did before the spindle journal, is to create a set of shims to go in between the cap and the main body. So I'm just making up a punch and die set out of 2 plates, another 2 plates. I do this because I want to keep the whole sentence right, not only in relationship to each other, but also in relationship to the base or the cap, because these won't be just square shims. They'll be nicely, hopefully, trimmed to follow this contour as best I can. I'll do that by hand. I won't shape this. That's too much work. So, so to get the bolt positions right, I'll leave these 3mm holes for the moment. I'll centre the centre this plate on the main assembly. Push it up against the bearings themselves, and just put a spot drill through this plate into the main body. Spot drill the location for the bolts, or the bolt holes in here, and that'll be done both sides. So that's this housing. There is a problem. There is a problem. So have a look. Have a look at the clearance here. Okay, that bearing's loose. that's not a problem. I can deck the main body off until that clearance is gone, and then go another 10 thou, 15 thou to allow for the shims, or the shim thickness. But the problem I've got is, main problem I've got is, notice the size of that gap there, and now notice the size of the gap. It's about double the size. I know that I can get a little bit here and a little bit here. I know that the steel core in the mould was not sitting level. It dropped down on one side. So I know I've got that journal there is not parallel to the face. Yeah. And that's quite a bit. I haven't measured it, but I know most of it is there, because on this side the same thing has happened. That journal is not parallel to that face, and it's not parallel to that face. And the differences there are the journal to the base face is 12 thou thicker on thicker on one end than it is on the other, and the difference of the journal to this bearing cap face is 4 thou. I've done those measurements by a comparison of that on both ends, using a reference mark on this. So I use the same bushing and the same position, just in case. But there's no. That seems to be well made. It looks like it's pretty much very round. So I've taken that measurement. Then I've taken that measurement, and that's how I've got the. And again, that measurement both ends, and that's how I got the 4 thou difference of the journal to this face. So I just got to work out how I'm going to set this up on the faceplate on the lathe to fix this up. So the 4 thou to the journal, this bearing cap surface to the journal, that 4 thou. I could set that up on the faceplate and put a 4 thou shim in there, and I could then face this off 4 thou. That will then make that surface parallel with the journal. And then I go the other way around and I mount the now machined face surface on the faceplate, on the faceplate, and again shim that out, the 12 thou, to bring this base in line with that face and the journal. Hopefully that will work.
And I'm using the bushings for alignment.
Okay, off to the drill press. 3mm holes, then I can come back, align these ends up. There's a dot, there's a dot. It wasn't quite necessary to have it end on end, but it will once the 4 positions go in. It may not be that interchangeable. But the reason I did this was to just purely for aesthetic reasons. The alignment of the cap to the main body was best in this way than around the other way. If I line it up here, I then have an edge and a lip. So that was the original reason. It was just to align the cap with the aesthetically with the quill support. Alright, enough yabbering. I'll now drill these out, then I'll be back. See you shortly. Well, there we go. I've drilled the 4 holes. I've aligned it as best I can on the joint edges. If it's a little bit out, doesn't matter. I could make these top holes, give them a little bit of wiggle room, about a 32nd larger drill size. But yeah, we'll see how we go. These are pilot. Again, another set of pilot drill holes. I still have to work out what depth those holes will be drilled to, but probably around 20. The thickness of the bottom here, I think that was 20 mil. But I'll do that on the drill press. There we go. Four holes. Alright. I was having trouble working out how to measure the relationship of that journal to this surface. I hand scraped this surface pretty well flat. It's a little bit down on the corner there, but I know this has got to be machined off anyhow, but I needed a flat surface to reference off. So I know this surface is flat and parallel. Problem is this journal is great, but it's not perfect to measure off. So at first I tried with the expanding inside mic in there, and that one, and then making the comparison to find out how. I know this journal is not parallel to that surface, or this surface is not parallel to the journal, and it's actually kicking up, and I need this surface to be parallel to the journal. Anyhow, I tried that, and I was getting varying results. So I needed a way of measuring the depth from the face to the bottom of the journal. Tried a couple of different things. Took me ages to work it out, but what I've come up with is pretty much. I know the top of this cap is not level. Again, that's got to be decked off. Well, I know it's not level, so I'll centralise this cap with the vice. Beautiful little vice. It's one of these, it's one of those Indian ones. It's very heavy. So what I'm going to do is, that's 1.776. That's 1.768. So we've got a difference of what did I say, 7.6. It's 8 thou. 8 thou, so we'll go half of that, 4 thou. So 872 is 72. So I'll put this bloke on 7.2. Then zero that. So I have a difference of 391 thou. So that distance from that face to there, less the distance of that, gives me 390. That's the size of the exposed part of the bush. And zero that. That's 866 less 390. So we've got 6, 7, 476. Is that right? 390. Yep. 0.476. That's the depth on that side. And then we just do the same on this side. Come on, open up. And that's sticking in 434 and a half, we'll say 435. 435. One. We've got 41 thou difference. So this is up 41 thou. I must recheck that because I had 51 thou. So anyhow, I'll recheck that, but at least this gives me the depth of that journal in relationship to the bushing that's going to sit in there rather than that little bit irregular surface. Anyhow, I'll recheck my calcs because I'm 10 thou difference, so I must have done some sums wrong somewhere. Ha! Wouldn't be surprised. Catch you later.